Hey dudes, Dude the Builder here, and in this episode of Zig Master, we're going to be talking about structs in Zig. So let's get started with a very simple example. Let's say here const point equals struct x f32 and y f32. So this is basically an example of a struct in Zig. As you can see, the fields are defined here by specifying the name of the field, an identifier, and separated by a colon from its type. In this case, they're both F32s. Okay, and fields are separated in the struct definition by commas. You could also, as we're going to be seeing further along, we could also have other declarations inside of a struct. And structs are anonymous in Zig. That's a difference from other languages. So basically, this struct that we're defining here is going to be assigned a name, and the name is going to be point because we are assigning it to this constant named point. The identifier is point. So let's see an example of that in action. Let me define first here const p equals, and this is how we can declare here a variable, a constant in this case of type point. Let's say here 1.0 and y is 2.0, and here we're going to be using the type of built-in to get the type of p. And if we build and run this, you will see that the name assigned to that struct type is indeed main.point. Okay, and we'll see why it says main.point instead of just point further along. But as you can see, the fact that we are assigning it to this constant name point is what's giving it a name. When you are defining here in this assignment, you are defining this constant p of type point. You have to specify all of the fields. Let's delete here the y field. Let's try to run this, and as you can see, we get an error here, and it's going to be telling us that we are missing a struct field y. Okay, so one way that you can, if for example you have a situation that a field usually has what's known as a same default value, let's say here you can give it that default value. Let's say here 1.0, and now if we save and build and run, we can run it without any problem. Okay, so if the field is assigned a default value in the struct definition, you can leave it out when you are declaring a constant of that type. And this comes in useful when you're using a struct type as the type for a function parameter, because for example you could have like a configuration struct type, and you can give default values to the different fields of that configuration struct. And then when a user instantiates that struct type, they don't have to specify all the fields. So that's one way you can use that. As I mentioned, you can have additional declarations inside a struct. For example, let's make a function here called new, and we're going to pass in an x f32, y f32. And we are going to return a point. And here I'm going to be using what's known as an anonymous struct literal. The field x is going to be equal to x, and the field y is going to be equal to y, and that's what we're going to return. So here we can then call that function and say here 1.0 and 2.0. Okay, and we should have exactly the same behavior. Okay, in this case, this function, as you can see, it has two parameters of type F32. If, for example, let's define another one here called add, and let's say that A is of type point, B is of type point, and we're going to return a point. What we're going to do, we're going to return here dot x equals a dot x plus b dot x dot y equals a dot y plus b dot y. And let's add the semicolon. So now, let's say that this is P1. Let's delete this. Say const P2 equals point.new. Let's say 2.0 and 3.0. Now const C is going to be equal to P1 point dot add P1 and P2. And now let's print that here. Right here, our name, and let's build and run this. As you can see, C is a main.point and X is 3.0. In this case, we're seeing that it's being displayed in scientific notation. And here also we have the scientific notation 5. Okay, so that is working. But given that here this first parameter for this function is of the type of the struct where the function is being defined, and this also would work if it's a pointer. Okay, it could be a pointer directly to the type, or it could be a const pointer also. In either way, this is what you would call a method in other languages. It's basically, you can then use method syntax, which means that we can do this. We can do p1.add p2. Okay? And as you can see, the behavior is exactly the same. So when you do have a function, and that first type of the first parameter is the actual struct type or any type of pointer to that struct type, you can use this method called syntax, okay, on any of the instances. But you can also still use calling the function on the type itself, okay? That's basically how Zig handles this type of situation. Also, you will see that it's accustomed to call when you have this situation where the first parameter has the type of the struct. You can see that it'll be called self. But this is not a requirement of the syntax of the language. It just makes the code maybe a little more understandable for a lot of people. So here, for example, if we change A, and in that case, B would be, for example, a little more understandable if we say other. Okay? And we save this, and it works just the same. So that's an example of having a normal function inside of a struct and a function that could be treated as a method. You can use a method called syntax. Also, as I mentioned, other types of declarations that you can have inside of a struct. Let's define here a var called increment. No, let's call it step. And it's going to be of type F32, and let's give it the value 1.0. And let's define a constant here. Let's call it origin, and it's going to be a point with x, dot x equals 0, dot y equals 0. Okay. And now in our code over here in main, what we can do is let's define here, say const d equals point dot origin. Okay, and let's print that out. D. Okay, and there you see we're using that constant defined inside of that struct. And let's add another method here called increment. Let's call this self once again, but this time we're going to be receiving a pointer to a point, because we're going to be mutating this instance, and we're going to be doing a self.x plus equals point.step. We're going to be using that variable. Let's do the same thing for y. And now here we got to turn this into a var so we can mutate it, and we call d.increment. Okay, so let's see if this builds and runs, and there you go. We have that it's 1 instead of being 0 as is declared in the origin constant. It's 1 because the increment method was successful in mutating that instance. Okay. So as you can see, the struct can have fields, it can have variable and constant declarations, it can have functions, it can have methods, and basically this gives structs this functionality. They can be this data structure with fields, but they can also be just a namespace where you can have declarations. And as a matter of fact, that's what happens basically when you have a Zig file. A Zig file is basically a namespace. It's basically a struct. So we'll see an example of this for, let's create a new file. Let's call it point.zig. Okay. And what we're going to do, let's go back here. Let me take this and copy it. Let's paste it here. And let's just eliminate this. Let's save this. Let's go back here. Oops. And now, instead of having this definition here, let's delete this, and let's do an import of point.zig. Okay, but we're not finished yet, because as you can see, now we have these errors here, and they're underlining our identifier point. And this is once again stressing the fact that structs in Zig are anonymous. In this case, we don't have that declaration as we did in main.zig of the constant called point. So now this struct doesn't know what name is being assigned to it, basically, and this identifier point doesn't mean anything. But we can solve this with a built-in, okay, and we're gonna place it here after the fields. Let's say const point equals at this. So this built-in called this will basically return the type of the struct that contains it. And in this case, the struct that contains it is this file called point.zig. Okay? So if we save this, we try to run this, it's not going to run. And what you're going to see is that we get a series of errors that say that for example, here new is not marked pub, and when the struct was defined in the main.zig file, we didn't have this problem, because if it's in the same source file, you can access all of the declarations inside the struct. But when it's imported from another file, you have to make them public. So in this case, let's make this public and this one, and our functions and methods, let's do the same here. Okay, so that would be problem. That's all of it. Let's try to run this again, and there you go. Now it works. Okay, let's go back to main.zig. So as you can see, when we import a file, a Zig file, we're basically getting a struct. It's the same exact functionality, with the difference that since now we're dealing with a different source file, we have to explicitly make the declarations that we want to use public. The fields are going to be public by default. You cannot make them private, but the declarations are going to be private unless you use this pub keyword in front of them. Okay, and as an example of using this var, let's change that var. Let's say here d dot has to be on the type itself, dot step equals 2.0. Save this and build and run, and there you go. Now it's 2. Now if you don't like this scientific notation, basically the default display for your struct, you can control that with custom formatting for your struct. Let's go back here to our file. If you go to the documentation of the standard library, and specifically the stud fumpt module, you're going to see the definition of a function. I have it here saved in a buffer here. Let's paste it here, and it's called format, and it's going to have this signature. It's a public function called format. The first parameter has to be of the type of your struct type. In this case, it's going to be point. The second parameter called fumpt is a comp time string, and this is used for more advanced functionality that we may see later, but we're not going to discuss right now. Usually you don't see much code when you're defining custom structs. Only in special situations they're making use of these, the fumpt and the options parameters. You're going to be using most of the time your type, which is the first parameter, and this last one, which is a writer, which is any type, which is basically how we deal with the writer interface in Zig. So as you can see here, we're assigning the fumpt and options arguments here to the underscore because we're not going to be using them. And what we're going to be doing then, let's do here a try writer.print. And let's say that we want to format it like this. Point, and we open curly, and we're going to use double curly braces, because the single curly braces, opening and closing, are used for the placeholders in our format string. But if we want to actually add curly braces to the output, we have to double them up like this, okay? And in here, let's do .x equals and this, and then .y equals this. Now what we're going to do here, we're going to be using our field names yd as our format specifier, which will format a number in a friendlier format. And here, let's use our field name x, and once again d, the format specifier. And let's now use self here as the actual arguments. So what we have here is that we are now controlling that format for our struct. Okay, we're defining a custom display format when we want to print our struct. And now whenever we print our struct, let's go back here to main, as we're doing here, and we're just using this placeholder which will invoke that custom formatting if you have that format function defined in your struct. So let's build and run this. And now, as you can see, we get our friendlier formatting here, okay, for the numbers. If let's go back here and let's add some, for example, we want to add a couple of .2 here, which will add a couple of decimal places. This, save it, let's run this again, and there you go. So you can have total control of how your struct is going to be printed whenever someone uses that's default placeholder empty, the empty braces like this. That format function is going to be used if it's defined in your struct. If not, it's going to be using that default formatting as we saw, which in the case of floating point number is going to be using that scientific notation. So basically, that's what I wanted to demonstrate in terms of structs in Zig. As you can see, they are quite versatile. They allow you to have different types of declarations. You can have use them as namespaces. They don't have to have fields. You can just have a struct that only has variables, constants, and functions. And that's basically, for example, here, this main.zig file right now, it's basically just a namespace that has this const point declared here and the function main. But this is basically a struct with, and also this const std for the standard library. That's basically, it's the same rules basically. We don't have any fields here, but it's the same rules apply as when we define a struct. So that's all the flexibility that you get with struct in Zig. So I hope you find this useful. Dude the Builder here. I'll see you in the next one.